Hello, good afternoon. It's finally nice to meet with you. I appreciate you taking the time to come in so that I can give you a little bit of education about ADHD and how it's affecting Jacob's brain. So, there's a lot of confusion sometimes about what's going on, and I thought that by putting together a slideshow, that it might make it a little bit easier for you to understand. Okay, so what is ADHD? ADHD is attention deficit hyperactivity disorder, and it is a neurobiological condition that affects the brain. Symptoms of it include inattentiveness, hyperactivity, impulsivity, lack of focus, learning difficulties, and behavior problems. All of the things that we have seen in displayed in Jacob. Now, the causes, there is not an exact cause, but research has shown that the following are contributors: genetics, environment, chemical differences, brain communication differences. So, all of these things they have found play a part in ADHD. Okay, so here we have a diagram of the brain. As you can see, it is separated into different regions. And there's the frontal lobe, the parietal lobe, the temporal lobe, and the occipital lobe. As I have put a image here that breaks it down just a little bit more, and there are parts of the brain that ADHD affects. When a child has ADHD, the brain does develop in the same way. However, development is slower in certain areas of the brain. And we're going to discuss this. I'm going to show it to you through this slideshow. Over time, depending on the severity of symptoms, the brain might not reach the same level of maturity as the non-ADHD brain. So, how does ADHD manifest in the brain? Again, here we have a diagram of the child's brain, and it's labeled with different parts. The frontal lobe is the front of the brain, and it's behind the forehead, and it's called the frontal lobe. And this part helps people organize, plan, pay attention, and make decisions. The amygdala is an almond-shaped structure in the limbic system, and it serves as the center for emotions, emotional behavior and regulation, and motivation. So these are two, as we go, we're going to continue, but as these are two of the parts that has been shown in the brain that has been affected by ADHD. Reticular formation. Now, this is a major relay system that receives incoming stimuli, and it puts the brain on alert, ready to respond. And it also regulates awareness and sleep. A deficiency here can cause inattention, impulsivity, or hyperactivity. Okay, so it's taking in information from stimuli, from touch, pain, what they see, what is seen, what is heard. The basal ganglia, it's not specifically one thing. It's a group of neurons located at the base of the forebrain, and it is involved primarily in processing and movement related information. A deficiency here can cause brain communication to malfunction or short circuit, and that can result in inattention or impulsivity. There's also a breakdown. The healthy brain effortlessly directs every thought and action. However, people with ADHD tend to lack, or should I say, they have somewhat of a breakdown in the chemical messengers. And what happens is that chemicals are known in the brain as neurotransmitters, and which are essentially chemical messengers that move messages from one brain cell to the next. And in the ADHD brain, the messages are not passed effectively between the neurons. Dopamine is a major transmitter, and that has been shown to not work effectively in the ADHD brain. In other words, there are essentially too many dopamine transporters in the brain with not enough receptors. And that means that the dopamine moves too quickly for the messages in the brain to be picked up. Okay? And dopamine is important because it helps control the brain's reward and pleasure center, and it's essential for sustaining attention and staying motivated. It helps children predict how rewarding a task will be. So because the dopamine doesn't work effectively in the ADHD brain, routine tasks with very little reward don't seem interesting. So it's hard for kids to get started on or stick with things without getting distracted by something more interesting. Okay, so the short circuit between the dopamine and the way that it's carried out through the brain definitely affects the way the child deals with tasks. So these are just main parts of the brain that ADHD affects, and I hope that this presentation was able to give you a better understanding of what's going on in the brain. And if you have any questions, you can ask them, and we can discuss further what the best course of action can be for Jacob. Thank you. Do you have any questions?